Hello and welcome to the Modular Livestream. Today we're excited to introduce Modular Platform 25.5 and walk you through everything that's new in this release. I'm your host, Caroline Frasca, and we have a great lineup of presentations ahead. We'll start with an introduction from Tim Davis, co-founder and president of Modular. Then Newton, Jain, and Deep Dhillon will take us into Large Scale Batch Inference powered by Mammoth. Brad Larson will follow with a look at what's new in MAX for 25.5. Next, Joe Lazaire will walk us through the latest Mojo updates. And finally, Ehsan M. Kermani will share what's new with our PyTorch integration. Be sure to drop any questions in the comments and stick around for a live Q&A with the team at the end of today's event. And with that, let's kick things off with Tim.
Hey everyone, I'm Tim, one of the co-founders here at Modular. Thanks for joining us today. The 25.5 release is live, and we're excited to show you what's new. Everything in this release is designed to give you more power and flexibility when scaling AI, and it's ready to use today. At the center of this release is the new Large Scale Inference Batch API, a solution for businesses and developers to handle high volumes of LLM requests with speed and cost efficiency, all built on top of Mammoth, our massive scale inference cluster management infrastructure. It's built for high throughput asynchronous inference. It's fast, it's accurate, and it delivers the lowest cost per request of anything in the market today on 20 plus of the most important open source models. If you're processing massive data sets or captioning billions of images or running batch jobs across clusters of GPUs, the Large Scale Batch API gives you an efficient, reliable, and secure way to do that at scale. You keep control of your data, and we maximize performance for your specific model and traffic profiles. It's already running in production, powering workloads at San Francisco Compute Company, where price, scale, and speed matter most, and we're just getting started. Get in touch to try it out today by talking to us at modular.com or go to sfcompute.com/inference. But 25.5 doesn't stop there. No, this release also includes the open source launch of the MAX Graph API, an early preview of how you program the engine that powers incredible computation across Mojo and MAX. It's a powerful and flexible way to build models that run efficiently on modern hardware. And with MAX, we continue to improve powerful AI serving features like speculative decoding and prefix caching, along with a new preview support of LoRa adapters. Lastly, Max's base Docker container is now under 700 megabytes and continues to drop in size, enabling simpler and faster deployments. Incredibly, we are now more than 93% smaller than the latest Docker container for VLLM version 0.10. For PyTorch developers, we continue to expand early support for custom ops written directly in Mojo, and you can now pass full MAX graphs as PyTorch custom operators. On the language side, Mojo 25.5 brings multiple improvements to string literals, a standalone Mojo conda package, and parameterized aliases, which provide more expressive power when working with generics and shared definitions. We also have a bunch of new improvements to Python Mojo interop that you can check out. All of this comes together to make your models faster, your systems more efficient, and your workflows more flexible. We're excited to show you what's possible and can't wait for you to try it and give us feedback. Let's get into it.
Thanks, Tim. Now let's dive into one of the most exciting capabilities in this release, Large Scale Batch Inference. Newton and Deep will walk us through how Mammoth powers high-throughput production-grade batch inference, already live in production today.
Hi, I'm Newton Jain, product manager on the Modular team, and today I'm incredibly excited to present the next breakthrough in the modular stack that we were able to build through the large-scale batch inference service that is powered by Mammoth. Let's have a quick recap of what Mammoth is. Mammoth is a Kubernetes native, cloud agnostic, and hardware agnostic cluster management layer that allows you to deploy, scale, and manage your GenAI applications for millions of users. We were able to build a lot of innovation at the cluster layer Things such as smart routing, smart KV cache management, disaggregated inference, where we break down your worker pool into prefill and decode nodes based on your request type, smart scheduling, and many more things that allow you to scale out your applications and get the best performance and drive the highest utilization of the underlying fleet. And building out all of these capabilities requires a lot of overhead that we have completely abstracted through Mammoth. So you can interact with it through simple APIs while we take care of all the performance tuning and optimization for you. And all of this was built with one singular goal, which is to serve more requests at higher performance with fewer GPUs at lower cost. And since we have built Mammoth, a lot of customers came to us and they asked us to use Mammoth for these batch inferencing use cases, things such as image captioning, synthetic data generation, document processing and summarization, large-scale data labeling, mass text embedding generation for your vector database and RAG searches, and enterprise-scale reporting for BI and financial automation. We listened to our customers and built out the Mammoth Batch Inference service that offers state-of-the-art performance for maximum throughput and efficiency. It offers really small container sizes for lightweight deployment and reducing cold starts as you scale out to multiple GPUs. It offers enhanced monitoring for comprehensive visibility through the batch monitoring API, where you can list and get all of the batches that you have submitted and even cancel them. And you can get cluster telemetry through metrics and logs that allow you to troubleshoot in case things go wrong. This is a production-ready infrastructure that can scale to billions of requests simultaneously and reliably. And we offer flexible deployments where we can deploy the batch inferencing service within your own cloud if you have access to the GPUs, or we can deploy it in our cloud and offer you an OpenAI compatible endpoint that you can start consuming right away. And all of this converges into one major benefit, which is to give you up to 80% in cost savings. This is huge. And without further ado, let's jump into a demo and see all of this in action.
Thanks, Newton. My name is Deep, and I'll be showing a demo for Large Scale Batch Inference API powered by Mammoth. We'll be looking at image captioning use case, which is one of the most popular use cases for batch APIs. And for this demo, we'll be using a fun use case of captioning Pokemons. Let's have a look at what the input looks like for Mammoth Batch API. It is a list of different prompts that you will be asking the model, as well as additional information those prompts would need. For example, as I mentioned earlier, we'll be captioning various Pokemon. So in this case, the prompt is like identify the Pokemon and its strengths, as well as local paths to different images for those Pokemons. And these are the paths that are provided. We are OpenAI API spec compatible. So all the fields here are OpenAI spec compatible, where you can provide information like the method you want to use, URL, model, as well as any prompt.
This is amazing. So Deep, for this example, I know we picked up a fun Pokemon captioning use case, but customers can very easily replace that with any other captioning use case that they have with relevant attributes that they need, and the model will automatically classify and save the response in this format. So
yeah, exactly. That is the idea here, is that we are sticking and being very compatible with an OpenAI spec, so the options are limitless here.
Yes.
Now that you have this JSON-L file, this gets parsed into a tar file, as well as all the images here. And then with the beauty of Mammoth, you're able to store this on any storage solution that you like. And here in this case, we have picked an S3 bucket. And all Mammoth really needs to know are the pre-signed URL that it needs to use for downloading inputs, as well as uploading outputs. And as you can see, this is where all the tar file is stored.
So Deep, you're choosing pre-signed URLs because I believe this is better for security, and this also follows the best practices for submitting jobs to batch APIs. Is that correct?
Yeah, that's right. Yeah. So with the pre-signed URLs, you have a set amount of time those URLs are valid for. And so after that time is up, those URLs are discarded and not accessible to anyone. And also the data will stay on your premise and wherever you want to store it, giving you full complete control over your data.
Amazing.
Yeah, before we start, so let's generate some pre-signed URLs. In this case, the bucket is shown and where the file was uploaded. I'll use a script that we have created for us to generate pre-signed URLs. And as you can see, here's an input and output pre-signed URL that we'll be using, as well as all the time that we mentioned how it expires in a certain amount of time. Let's actually export these URLs so we can use them in an API call.
So while Deep is setting this up, essentially the idea here is you can bring any S3 compatible bucket that has your images, create pre-signed URLs, and start consuming this batch API instantly. And that's what Deep will show in a moment. And you will get responses back in an OpenAI compatible file format, and you can extend that to multiple use cases as well.
Yeah, now that we have exported these two URLs, we're ready to make a request. And in this case, making a request is as easy as sending a curl request to an endpoint for Mammoth. And in this case as well, we are OpenAI compatible, and we have fields like input file ID, endpoint, completion window. Not only that, we have extended the spec further by using metadata field where you're able to provide the model you want to use, output file ID, so you control where the data comes from as well as where the results are stored. In this case, we'll reference the input file URL as well as output file URLs we've saved recently. And here it's sent. And as you can see, the response that you get back is also OpenAI spec compatible. And here you see things like ID, as well as what kind of object you're working on, as well as input file ID that you provided, as well as the output file ID. Not only that, you also see a status that shows you clearly at what point in time is your batch at, so you can track and see the progress of your batch. And also you'll see a few things like request count that shows you how many requests has been sent, has been completed. And the idea here is that as the batch progresses from a life cycle, we report these numbers so a user can see how many requests have been completed and how far along the batch is. And also, as I mentioned earlier, we wanted to use an intermVL 38 billion model. We mentioned that in metadata, and that information is still preserved and provided to the user. And these statuses will evolve as the batch goes through its lifecycle. Let's try getting a status of the batch. As you can see here now that it's in validating state. In this state, our system validates all the input file URLs you provided as well as the output file URL. It would also validate if you can load the right model and other checks that it needs to complete to make sure that your batch can be in a progress state after this point. And from validating state, once it has completed all these checks, it will move it into an in-progress state. And from in-progress state, you will start seeing that these request counts and other information start getting updated based on the information the system will be reporting.
And this is very useful. So not only are you submitting batches, but once you have submitted a big queue of batches, you can actually monitor the progress of those requests through our system. And you can use APIs to list batches, get batches, or even cancel batches. And this level of observability helps you maintain and use systems at scale.
Yeah, exactly, Nathan. Yeah. And you can build your own sort of systems around this to understand what's happening as well as track and have full visibility for the system.
Mm-hmm.
Let's check it one more time, and now we should be seeing that it's actually in progress. So as you can see, it's actually in progress now, and it's just started, and hence there are no requests that has been sent. But if you were to run this status very shortly, you should see some of the request numbers should show up. As you can see here, a total has now actually changed to 596, and some have been completed, and some are still being processed. And in this case, this number will keep going up as the batch completes. And eventually, when the batch finishes, we also report information like token count, as you will see shortly. And just in the next few seconds, you should see the whole batch will be completed. Perfect. As you can see, the batch is now completed, and you can see the request count has been full 898 entries that we had earlier that we have completed. And as I mentioned earlier, you also see information like token usage. You see how many input tokens that were given, like prompt tokens, as well as how many output tokens that were generated, along with total number of tokens that the system processed. And since the batch is now in a completed state, it has uploaded the output of this onto the pre-send URL that we provided earlier. Let's have a look at that. Perfect. As you can see, there's actually a file there. So let's go download it. Sweet. So let's try to untar the file. And it comes with an output.jsnl file. It would also come with an errors.jsnl file if there were any errors, showing you exactly what were the errors and why it wasn't able to process the input for that one. Sweet. As you can see here now, we have outputs that came through. And in this case, outputs are exactly what we wanted it to show. In this case, we are able to see which kind of Pokemon they identified, as well as what are the strengths of the Pokemon. And in your case, it might look different, and you might be able to get any information that you like. And just like I mentioned earlier, this is also compatible with OpenAI Batch Spec. and you can use any OpenAI client to work with this API. And that concludes my demo, and I'll pass it back to Newton.
Thank you, Deep. That was an incredible demo. As you all saw, Deep used the intern wheel model for an image captioning use case. With the launch today, we are announcing over 20 plus optimized models across Qwen, Mistral, DeepSeek, Llama that are supported for this inference service across a wide spectrum of use cases. And we are happy to support any custom models that you might have. Just come and talk to us. And we would be very excited to support you in your journey in building breakthrough applications. We can't wait to see what you build next. Thank you.
Thank you, Newton and Deep. Now let's shift gears to Max. Brad is here to walk us through what's new in Max 25.5, from the open source launch of the Max Graph API to improvements that make it even easier to build performant AI systems.
Hey everybody, I want to talk about what's new in Max for our Modular 25.5 release. These additions focus on two areas we always strive to improve, making it easier to work with Max and accelerating its performance. Let's start with a big announcement in 25.5. We've open sourced all of the Python code behind our Max Graph API. That's 11,000 lines of new open source code at the heart of the Max framework. Max graphs are how we build and optimize AI models and other large computations. Each node in a Max graph is written in Mojo, and earlier this year, we open sourced the Mojo code for every Max kernel. Now we're making available the Python code used to construct the graphs themselves. Importantly, this includes all of our unit tests that show how to use each Max operation and construct graphs from them. Many developers are integrating AI coding agents like Cursor or Claude Code into their workflow. We've seen how these agents perform far better when they have code they can reference for how systems work, as well as examples of proper usage. So developers aren't the only ones who benefit from having all the code behind Max available to read. We've also made another improvement to how Max graphs are built. Many more errors are caught earlier in graph construction, often at the time of creation. This can prevent a ton of frustration when building and debugging a new model. We keep working to make the OpenAI compatible endpoints served by Max as fast and capable as possible. Performance enhancements in 25.5 include removing some expensive overheads when evaluating models using log likelihood. Among other expanded features, there's a new health endpoint for checking on your models during serving, and we've added the ability to provide file URLs for images to multimodal models. I want to highlight one new Max optimization, an acceleration in our prefix caching implementation through the use of a new token hashing algorithm. This new token hasher replaces the standard Python hash function with one defined in Mojo. We're now using Mojo to selectively replace slower Python code in real-world production use cases. This is the first of many applications we hope to see for the Python to Mojo interoperability we introduced in 25.4. So we hope you'll browse through our newly available Max graph code or take advantage of one of these new performance or usability improvements in Max within the Modular 25.5 release. With that, I'll hand you back to Caroline.
Thank you, Brad. A lot of exciting progress on the Max front. Next up is Mojo. Joe is here to cover the newest language features and improvements that make Mojo even more powerful and easier to use.
Hey everyone, I'm Joe and I'm here to talk about what's new in Mojo. Let's dive right into it. So the first key thing that happened with this release is the parametric aliases feature. Specifically, this allows you to just apply one parameter to bind to a struct that may have many parameters. So think of it as a compile time alias that accepts one or more parameters that produce values or types based on those inputs. This is very powerful to have in our metaprogramming toolkit. Consider this example on the right. We have this alias here, this parametric alias that takes one parameter, which is the tile sizes. It takes a number of integers. These integers are used to compute the complex layout parameter here that you see as the second parameter for layout tensor. Previously, in order to express this concept, we would have had to have a function that takes this same parameter that we then express this complex return type as the return type. And then in order to use this at the call site, we would have had to use the type of construct in order to call the function just to infer the result parameter. That's a little unwieldy. It's pretty complex for something that you can now represent very easily. This is a huge improvement in readability that is actively getting used in the kernel library. We hope to find more uses of it. We also have been working on expanding our consumer-grade hardware support across AMD and NVIDIA devices. On the AMD side of things, we've worked on the Radeon RX 7000 GPUs and the RX 9000 GPUs, in addition to the support we've already added in previous releases. We've also been working on the NVIDIA RTX 3090 series as well. Now, diving into more of the library side of things, outside of GPU support, there's various library constructs that we've worked on as well. Consider @parameter4 for iterating a range of values at compile time. This has now been expanded to work on a broader range of collection types, enabling things like @parameter4 in list literal 1, 2, 3. This allows you to express these concepts very nicely now. In addition to that, we've also made several improvements to strings and the usability of them. The big thing with this release is string literal is now non-materializable to string. What does that mean? So what it means is strings are a lot easier to use. Consider the before example where you had something like var x equal foo. Previously, this variable would have been a string literal with the contents foo. Now, that string literal materializes to a string, and what that means is you're able to use the full power of the string APIs that just make sense and make things easy. But don't worry, you still have all of the goodies as before when used in a compile time context. So you don't have to worry about things materializing to string when you weren't expecting it. In addition to that, we've taken a look at some of the string APIs to improve the performance across the board. Specifically, one of the examples of indexing into a string, the get item, it now returns a string slice, which allows you to avoid an allocation. Before it used to return a string. This is much better for performance. In addition to those string API improvements, there's been a couple of other things that we've been working on. On the language side of things, the @value decorator has been formally deprecated with a warning, and it will be removed in the upcoming release, the 25.6 release. Instead, use this new fieldwise init decorator, which replaces the @value, and it comes with a synthesized, copyable, and movable trait that automatically gets applied from the compiler. In addition to that, we started working on some things related to generic programming. We've added the iterator trait to allow for modeling types that produce a sequence of values. You can take a look at examples like list and span to take a look at their iterators that now model this iterator trait. What's next? Well, now we'll need to add an iterable trait and then work on generic algorithms that apply on an iterable sequence of things. Now we're going to take a second and talk about the distribution and package side and what's exciting ahead for Mojo. Now, the Mojo compiler and libraries can be installed separately from Max using the Mojo Conda package. We have two flavors of this. The Mojo compiler is a slimmed down package that ships without the tooling support in the LSP and debugger. So it's just a compiler, as the name says. However, there's also the Mojo compiler, which has full support for local Mojo development, Python to Mojo bindings, and Mojo GPU programming with the layout package coming alongside. If you want to use the Max Graph compiler and Python APIs for doing graph authoring, please continue to install the full Max or modular package. But this is a huge boost for those that are just interested in Mojo. One last thing before we go, we're now going to talk about the Python Mojo bindings updates. There's been a couple of exciting things that have gone on in this area. The highlight here is we now have support for calling Mojo functions that accept keyword arguments from Python. Consider the example on the right. This function foo accepts a keyword argument for the parameter y, and it allows support for multiple keyword arguments. Right now, you need to specify this as a type using owned quargs dict. Like before, Python object is still your go-to type. This just wraps all of them, and it allows you to unwrap this keyword argument in the body of your function on the Mojo side of things. This should allow for more expressiveness when using Python Mojo bindings. In addition to that, we've also added support for static methods. So now we have support for static methods and keyword methods, in addition to all of the previous method support in Python Mojo bindings. There's also been some updates for registering initializers that take arguments, expanding our coverage and support for what types of objects you can construct when using the Python Mojo bindings. Lastly, the Python convertible trait has been renamed to convertible to Python, so please update your code accordingly. That's it, folks. I'm going to hand it over to Caroline for the rest of the segment.
Thanks, Joe. To close out our release walkthrough, we'll hear from Ehsan, who's sharing the latest on Max's integration with PyTorch, which now allows you to wrap Max graphs as custom PyTorch operators.
I'm very excited to talk about PyTorch Custom Ops with Max and Mojo today. This feature bridges between PyTorch and Max and is a great way to get the benefit of Max and Mojo, especially for GenAI models that are mainly in PyTorch. Officially, PyTorch supports C++ extension as the only way to extend PyTorch. That means you need to write C++ CUDA code, configure your build system, handle Python bindings manually, compile for each platform, and also debug across multiple languages. As a result, you get slow development cycle, complex maintenance, and platform-specific builds. Now let's see how easy it is with Max and Mojo to write PyTorch Custom Ops. Max provides two main APIs that you need to remember. You can use GraphOp decorator for a function that uses Max Python API, or you can use Custom Op library to load your Mojo custom GPU kernel, and then you can use it as a normal op in your PyTorch code. Now let's see them in action in a live demo. Also note that all the code is available in our GitHub modular/workshops. So in this demo, I'm going to show you how to learn how to gradually replace any parts of a PyTorch model with Max and Mojo. For a demo, we are going to use a GPT-2 model, which is small enough to show here. Here is the model architecture. We are going to replace layer norm as the very first example, and then we are going to replace new Jello activation with our Mojo GPU and CPU implementation custom op. And then we are going to replace the whole layer, MLP layer, with Max. Here is a dialog bot that does text generation for us. And we have a sample of inputs that we are going to test against different cases. The first case is running the vanilla PyTorch implementation. So here are the results of our inputs. We get, for example, hello, how are you? I'm good, thanks. How about you? And etc. Now let's see how we can use GraphOp Max API to replace layer norm. We are going to use ops.layernorm, which exists in Max Graph API. To replace layer norm in PyTorch. So after wrapping it a function with GraphOp, we can use it like a normal function in a PyTorch code using PyTorch tensors. One thing to note that after this decorator is applied, an output is being included as the very first argument. This is being added as the first argument to enable highly efficient destination passing slide, which is very common. And then we can also test our custom op layer norm implementation against vanilla implementation in PyTorch. And later, and then we are going to iteratively replace the layer norm of our GPT-2 model with our custom op. Here, after doing that, we can see we have successfully replaced 49 layer norm operations. And then if we instantiate another dialog bot and pass the same test inputs, we can see we are getting exactly the same outputs as expected. Next, we're going to see how to use custom op library to load our custom op kernel. So in this case, GPU kernel. And for this case, we're going to have our own version of a new GLU activation in Mojo. One thing to note is if you are using Jupyter Notebook like this, we have a support for Mojo Magic in Jupyter. So after importing Max support notebook, you can basically include any valid Mojo code in a cell that's been activated by this Mojo Magic, and then it behaves as expected. So here, this is our new GLU custom op in Mojo that we are going to package. And here we are calling it on the Mojo package that we just made. And then we are going to make it as a PyTorch module to be able to replace in our GPT-2 model. And if we do the replacement, you can see that we have successfully replaced 24 activations. And if we create another instance of a dialog bot and pass the same test inputs, we are going to get exactly the same outputs as expected. Finally, we are going to surgically replace the whole GPT-2 MLP layer with Max. So this is the details of the layer. And if you go to the details, you can see basically this is an MLP layer. So followed by including actually a new GLU activation. And if we do exactly the same thing for the model surgery that we did before, we are going to see that we have successfully replaced 24 whole GPT-2 MLP layers with our custom layers. And if we instantiate another dialog bot and pass exactly the same input test inputs, we are going to get exactly the same outputs. And as a summary, so in stage 1, we ran the PyTorch model, vanilla PyTorch. In stage 2, we have replaced 49 layer norm and then 24 new GLU activation, and finally 24 whole GPT-2 MLP layers. Okay, and now that concludes this segment, and that concludes my segments. I hope that I've provided enough motivation to replace PyTorch ops with Max and get the benefit of Max at Mojo as quickly as possible. Thank you.
Thank you so much, Ehsan. That was great. We are going to open it up now for Q&A. So we'll answer any questions from the audience. If you have questions for the team, be sure to just drop them in the comments, in the chat, in YouTube, tweet at us, and we will answer your questions live. We're going to get started with this question. What features are coming soon for Mojo? Joe, you want to take that one?
Sure, I'm happy to take that. I think some of the big features that we talked about that we highlighted on the modular forum on the language side of things would be requires clauses. This is one of the best things that we're excited about on the library side of things. What this means in practice is there already is a proposal doc you can go read on our GitHub. But what it means is all of our constrained uses in the library that lead to long elaborator errors, those now get much earlier, better error messages because you can express these same constraints on like a struct, a function to express a set of constraints that will yield a much better error message. That's one big thing on the language side of things. There's another thing that's going to allow us to delete a bunch of code on the standard library side of things, which is default methods. And so where we're going to apply this on the library side of things is a lot of things are field-wise or member-wise defaultable. And so what this means is we can get synthesized like dunder EQ, dunder any, and all the comparison operators that just do member-wise comparison. And so I think this is going to estimate several thousands of lines of code to be deleted from the standard library, which will be great. We're really excited about those on the Mojo language side for Q3.
Awesome. Thank you, Joe. We have this question from Mojonized. Can production applications use batch processing to handle requests from, say, 5 different users at the same time?
Yes, I can take that one. So the answer for this is yes. When you use our batch API, we create an authorization token. And when you use that authorization token, you can submit requests from multiple sources. It basically gets queued. And as soon as the compute is provisioned, we start processing those requests and we start saving the results in the preferred destination that you have. If you have different use cases that you don't want to share the authorization token on, you can just create 5 different authorization tokens that will create 5 different queues, and your request will still get processed in the most optimal price performance fashion. And then again, you'll get the output as you need.
Great, thank you. From Cyan Starlight, what is the roadmap for FFI and accelerator support?
I'm happy to take that, unless you want to, Brad.
Oh, Brad, I think you're muted.
Oh, go right ahead.
Okay, sure. So as far as accelerator support, one of the things, as we talked about at the community meeting yesterday, we do have plans for Apple GPU support. So depending on your definition of accelerator, that is definitely the most immediate thing on the radar. As far as future accelerator support and like what sort of hardware vendor and what that may look like, we don't have any details that we're ready to share today, but it is definitely something that Modular is well equipped for the future. As far as FFI, I don't have any immediate plans to share for the purposes of today. This is something that we're thinking about what the North Star vision looks like. It's being driven immediately by the Python Mojo interop use cases, but this will reasonably extend to how you may do C or C++ interop very well, but we don't have any immediate plans for that in the radar for 2025.
And I guess kind of building on that, are you planning Apple GPU support from DDM?
Yes, I do want to go back to the other question though, just for 1 second. If you do have specific concrete things that you would like to see in enhanced FFI support, I'd love for you to file a GitHub issue or a proposal. And we can definitely take this to the team and fold it into how we're thinking about North Star for FFI and interop between languages. So definitely feel free to contribute on that front. As far as Apple GPU support, do you want to talk about that, Brad? Otherwise, I'm happy to talk about it.
Sure. I mean, I got to provide a little bit extra color on it. I think later today we'll probably have a YouTube video up where you'll be able to see Amir presenting like the fantastic internals about the work that has led to the initial Apple's GPU support. You're going to start to see rolling out in our very latest nightlies. So if you want the very latest, check out our nightlies. We will put together a more formal post about when the support is ready for people to start working on. This is an area that we'd love to have community engagement to help us bring up kernels and model support on Apple Silicon GPUs. We're trying to get all the basics laid out for you. And again, if you really want details, I know people have been asking about how does this interact with the Metal backend. I highly recommend watching Amir's presentation on it. It's excellent work that he's done there.
Maybe I'll just add, is it worth, Brad, talking a little bit through how we tier out support? So if you go to docs.modular.com/max/FAQ, we do have different sort of tiering structures on support. So maybe you can frame that a little bit for folks so they understand it.
Absolutely, yeah. As Tim mentioned, we have a published list of several tiers where tier 1 is these are the GPUs that we run in CI every day, and so we know they work. We guarantee that they work well. And we try to optimize as much as we can for those. Those are our premier data center GPUs that we target for our enterprise applications, and so we test against those, and so we qualify those as tier 1. Tier 2 are the GPUs where we've seen them work very well. They are working right now in the community. They can run full max models. But we don't run them every single day in CI, so there's a possibility that regressions may slip in on those, but we feel fairly confident about them. Our tier 3 GPUs are the ones that we were just bringing up. They are ones where like we may not have full max model support or optimized max model support for, but maybe we have like a lot of the fundamentals in place for being able to run GPU functions in Mojo, do the kind of program that you want to do. They're like experimental GPUs that are on their way up. And so we start them at tier 3 and then kind of like work up the tiers as we add support for them and as community members report that support is getting better for them.
One other thing that I'll add about the Apple GPU support, you're going to start seeing some things roll out in the latest nightly. So you can't play with it quite yet, but just give us a couple days here. You'll start seeing things roll out in the changelogs.
Jefferson asks, how does this work or compare with Max Silicon and MLX? Brad, you want to talk to that, or Jay?
Sure. Yeah. I mean, it's like MLX as a whole. So MLX is Apple's research scale framework for building out machine learning models. It has many similarities to what we have built in Max at a core level. And so, like, as far as a direct, like Max itself compares directly with what you have in MLX. So you can build similar models, express them as computational graphs, and fully optimize for the various systems. What I will say is we are building Max to be as broad a platform as possible in terms of hardware support. So you will see, like, our ability to work across NVIDIA, AMD, and relatively soon Apple Silicon GPUs with a single code base, with a single model definition, and hopefully with like the best possible performance we can get on each one of these hardware accelerators that you have out there. And again, like, we've talked quite a bit about like how our implementation is going to work, but nominally, like if you're deploying a model, once support is up, you won't notice a difference at all. It'll just run on the Apple Silicon GPU with the same model code that you would deploy to NVIDIA GPUs or AMD. But again, if you're directly programming the GPUs, you'll be able to program them using Mojo, using the same interfaces that we have out there. There will be, of course, tuning that will be appropriate for Apple Silicon GPUs for the unique characteristics of those GPUs.
And maybe one thing, we've got Caroline back, but maybe one thing it might be worth mentioning is how are we thinking about quantization support on Mac, and sort of for folks who want to run larger models on their local machines, how are we thinking about that?
Sure. Like right now we have two tiers of quantization. So we have right now built out for GPU, we have the GGUF compatible like quantizations, like the Q40, Q4K, Q6K kind of quantizations that are very popular on CPU models. On GPU, we have initially built out GPTQ and AWQ quantizations because those are the ones that are most popularly used for enterprise workload quantization. But there's nothing stopping the Q4K and Q4 support to migrate to GPU. I will say all of our dequantization kernels are fully in open source, and we love help if you have a strong interest in pushing like quantization on new platforms. You can contribute to our open source kernels today and help us migrate those across. But we at least have the basics there for those two levels of quantization, and we'll hopefully expand those in the future.
Yeah, and I think that's an area, to your point earlier, Brad, we would love community contributions if you're interested in helping. Obviously, Mac is going to be a huge deal for folks to be able to run a bunch of this stuff locally. So yeah, it's an awesome opportunity to go and look at the open source kernel code we already have in our GitHub repo. Please go check it out. And if you can look at the GPU tiering under the FAQ in our docs, we would love your support in bumping up hardware into higher tiers.
Thank you. Apologies for the technical difficulties, but that's how you know that we are truly live. So next question, Gregor Riznar, is there a noticeable difference of requires usage in compilation times?
It's definitely something we're interested in measuring, but we can't actively measure it yet because we don't have the language feature yet. So stay tuned. If you think about this, like if you compare it to C++, for example, if you do compilation time measurements between concepts and like enable if, you'll see that concepts, which is roughly the equivalent of requires clauses here in Mojo, you actually see a good boost in compilation times. And so I may expect something similar in Mojo, but I can't promise anything until we have the language feature to play with it.
That's fair. Another question from Gregor. Is conditional conformance going to land in 2025?
This is an interesting one. So if you look at one of the things that I did not mention in terms of what is coming in Mojo soon, I did not mention struct extensions. Struct extensions was on the Mojo roadmap for Q3, Q4. We may rework that a bit in terms of working in conditional conformance to some extent to help us further along with struct extensions. So that's still getting actively discussed right now. Even like I was just in conversations yesterday where we're still figuring out some of the details. So stay tuned. You'll be the first to know when we know.
Thank you. From Dalton, when can we expect to find GPT OSS 20B and 120B in the model list? Brad, do you want to take this one?
Sure. I mean, I can say that like everybody else, we know that there's huge demand for these OpenAI open source models. The team is working on them. They're speccing it out. Can't promise any timelines on it. But we know that people are very excited about being able to run these in Max. And so we're building out the components right now.
Thank you. From Samuel, is parametric traits coming in the next stable release?
I'll take that one. Since I know when the next stable release is, I'll give everyone here a little bit of a preview. It's going to come towards the end of Q3, and I will say with 100% certainty, parametric traits will not be in that next stable release. Note that parametric traits was not on our Q3 roadmap. It is something that we're actively considering, but it will certainly not be in the next release. Sorry to burst the bubble there. I'd rather be completely transparent though about what is going to make it.
Totally, and we did share a Q3 Mojo roadmap update in our forum. We'll link to that page in the description of this recording as well.
Yeah, that would be great. When I keep mentioning the roadmap, that's what I'm referring to.
Definitely. Will we be able soon to use Mojo without Max for general purpose programming? I think this kind of leads into sort of like the packaging updates as well. I don't know if Brad or Joe, you want to take this one?
I'll let you go for it, Brad, if you want.
Yeah, I mean, the answer is yes. So as of the 25.5 release, we have a standalone Mojo package, and so you can go and install it if you want to work purely on Mojo programming. You want to experiment with that even for things like doing Mojo-based GPU programming, working on kernels, working on other projects that are purely like Mojo and direct dispatch onto the GPU. You can do that today with our Mojo and Mojo compiler packages. And so we've done a lot to streamline all of our packaging from modular all the way down. I think the modular install is 1/4 what it was at our last release on disk, and so what we've done is we've added granularity to all of our packages, so you can now get the components individually that you want to have for just doing the task that you want to do. This allows people to very easily get up to speed, get quickly set up for a development environment for just the tasks they want to, and then scale up to the other parts of the Max stack as they need them.
Thank you. What are the best entry points into Mojo for people jumping in? I think it kind of depends on what you mean by jumping in, but maybe we can kind of talk about just from a educational point of view, some recommendations.
I think it's a great time to highlight Ehsan's, GPU puzzles. You want to talk about that, Ehsan?
Yeah, absolutely. I think, first of all, we have Mojo manual. If you go out to our docs, we have a fantastic team working on writing the manual and basically learning Mojo. And then, yes, if you're interested in learning Mojo in the context of GPU programming, we have GPU puzzles, which is puzzles.modular.com. And I hope that you can get a lot of benefit from that as well. So yeah, and then we are also trying to refine all of the educational materials that we're producing. So give us a lot of feedbacks, please.
Yeah, I'd also say check out GitHub too. There's a huge amount of existing Mojo code that's already in the GitHub repo, and so you can go and check that out. We have a wonderful forum that you can join where there's a lot of community members that can provide support. Plus, you get access to the whole team. There is also a Discord, but the forum is probably the better place to be asking questions. But outside of that, yeah, there is a huge amount of examples. I think one of the things we'd love feedback from too is just, when you're onboarding, particularly for new users, what is that experience like? Do you feel that there's enough material? If there's things missing, what can we do better? So please be vocal about that and give us that feedback in the forum as well.
Yeah, absolutely. Is there any important thing to be implemented which could be a boost to be hired? I don't know that we can speak to hiring necessarily, but maybe we can kind of reframe as what our most desired community contributions might be. I don't know if Brad or Joe, you have thoughts you want to share on this?
I can talk
Go
a
ahead,
little.
Brad.
Yeah. So I've actually put out I put out a recent call to action. So it's just highlighting one thing. We're looking for people to contribute kernels. And one area is we've been expanding our consumer AMD GPU support. And we'd love help with that. We know a lot of people have consumer AMD GPUs at home in their laptops, in their workstations. And so we've brought up a lot of the basics there. But we love help in that last mile of implementing, say, an optimized flash attention kernel for the consumer rated AMD GPUs to unlock larger scale models being able to run on them. And so if you go to our forums, you'll find I have a post there. Kind of describes the work that we've done so far, where people can help out and how they can contribute. That's just one area. We've also put out calls to action on specific kernels that we'd love to see across the board. Anything like we were just talking about quantization, expanding some of our quantization to GPU, expanding the types of quantization we support. And so there are many places that people can contribute on the kernel side that I think would be fantastic for folks to work on.
Awesome. Thank you, Brad. Last question that we have time for today from McGregor. Struct extensions, if it will land, is it planned to perform cleanup across the whole standard library and move Python-like functions to extensions to avoid the current mix-up of Python-like stuff in pure Mojo?
Yeah, so we actually had a deep dive, and it was a 3 or 4 hour thing where we walked through various user stories that we would accomplish with this language feature of struct extensions and started scoping them out. And one of them is, like you pointed out. So specifically in the standard library, if you look in the SIMD struct, there's a constructor that takes a Python object. If you had this functionality, you would allow you to separate the core type functionality from the things that are some other type at a distance that's kind of sneaking into your SIMD type. You see that a lot with constructor overload sets in the standard library. That would be an organizational cleanup. That would be one user story that would come out of struct extensions, yes.
Awesome, thank you. I think that's actually all of the questions that we have time for today. Thank you to all of our presenters. Thanks to everyone who submitted such great questions for the team to answer today. And thanks for sticking with us through some technical difficulties. As always, you can post any other questions for the team in our community forum at forum.modular.com. And then if you're in the greater Bay Area, don't miss our upcoming meetup with In-World AI at our modular headquarters in Los Altos, California, on August 28th, and there will also be a virtual attendance option available as well if you're not in the Bay Area. But thank you so much for joining us today, and we'll see you next time.
See ya.